Have you ever watched a pianist's fingers fly across the keys, or a guitarist effortlessly switch between chords, and wonder, how do they move so fast, and with such skill and precision? Motor learning, seen through guitar and piano practice, alters a musician's hand dexterity, affecting motor unit recruitment, coordination, and speed. Independent finger control is naturally restricted by the anatomical structure of the hand and by neural mechanisms. So complex tasks such as playing an instrument require adaptations in the brain and in the hand. Research on pianists and guitarists demonstrates structural and functional changes in the brain, particularly in regions involved in motor control, coordination, and interhemispheric communication. According to a 2010 research study published in Frontiers in Psychology titled Musical Training, Neuroplasticity, and Cognition, we have found that imaging shows prolonged and intense musical training, especially starting at an early age, can cause significant structural changes in the brain. Musicians in particular show greater cerebellar volume and a larger corpus callosum. We know that increased cerebellar volume leads to better motor timing, so movement is executed more accurately, reducing timing errors between muscle groups. One of the cerebellum's primary roles is to receive sensory feedback about motor actions and compare it with the intended movement. It then adjusts the movement by sending the corrective signals back to the motor cortex. With an increase in cerebellar volume, this error correction process becomes more efficient. Fine motor actions, such as finger movements while playing the piano, or daily activities like typing, can be fine-tuned in real time, allowing for more precise and controlled motions. The corpus callosum is a major white matter tract that connects the left and the right hemispheres in the brain, facilitating communication between these two hemispheres. A larger corpus callosum allows for faster and more efficient transfer of motor commands and sensory feedback. This is critical for bimanual coordination, when both hands move independently yet harmoniously. Non-musicians tend to have stronger interhemispheric motor interference. This means that the movement of one hand can unintentionally influence the movement of the other hand. Pianists and guitarists develop a greater ability to suppress this unintentional influence, allowing each hand to move more independently. The corpus callosum exhibits experience-dependent plasticity. This means that in response to prolonged and intense training, it becomes physically enlarged. This allows for progressive refinement of motor control, making complex finger sequences feel effortless over time. These changes we see in the anatomical makeup of the brain help musicians to execute movement with less neural effort. Authors N.S. Furia and others wrote a research article titled The Impact of Musical Training on Hand Biomechanics. They wrote, asymmetry in specific cortical areas in the motor and sensory regions suggests some evidence of hemispheric specialization. This means that brain adaptations in musicians lead to greater movement precision and efficiency by reducing interhemispheric interference. Professional musicians rely on a more refined and efficient neural network, meaning that they don't have to consciously think about the movement patterns in order to produce music. They have a quicker and more synchronized motor response due to increased white matter, and inefficient muscle activity is eliminated with the help of specialized neural pathways. And there are also fewer neurons to achieve the same movement of a non-musician. This leads to less energy consumption overall. Piano and guitar playing has a positive effect on fine motor skills, and because of that, there could be a potential use for piano and guitar lessons in rehabilitation. A research study published in the journal Neuroplasticity, Disease, and Treatment in 2015 entitled Piano Training in Use with Hand Motor Impairments and Damage After Developing Brain found that piano training enhanced fine motor skills audio-visual integration, and hand-eye coordination due to the repetitive nature of finger movements and real-time auditory feedback. These findings were measured through a battery of hand function tests. While the participants in the study did show massive improvements, there was a lack of a control group, and that made it difficult to tell whether these effects were due to the piano and guitar training itself or if it was due to natural physical development. However, a parallel study found that after 18 months of piano training, children with cerebral palsy showed enhanced connectivity between the primary motor cortex and the cerebellum, just as observed in professional musicians. This suggests that there are neurological benefits to playing a musical instrument, and it may be significant enough to include music lessons in rehabilitations. The ability of musicians to perform rapid, precise, and coordinated movements is not just a product of talent. It is also a testament to the brain's remarkable ability to adapt and refine motor control through practice. As we have seen, playing the piano or guitar reshapes the brain, allowing for greater dexterity, efficiency, and even potential therapeutic benefits. Long-term musical training reshapes the brain and enhances dexterity, coordination, and efficiency while reducing neural effort. We examined the potential for piano training and guitar practice to be used in motor rehabilitation, and this shows promising effects on fine motor skills and brain connectivity. So the next time that you hear a beautiful piano piece or watch a guitarist's fingers effortlessly glide across the strings, remember, it's more than just music. It's the result of years of training, sculpting the brain into an engine of precision and efficiency. So whether you are a musician or not, this research highlights the incredible truth. The brain is constantly changing, adapting, and improving, and with the challenges we give it, it will continue to change. So why not pick up an instrument and see how that instrument changes you? Thank you.